Again, this is for general sine and cosine function. So you write it together. So you just write from the top, from the investigation, for the general sine and cosine function, this happens. So you can label it accordingly. Maybe let's wait because of the time, so we don't waste time copying. We actually don't have all day. So, again, this A affects the amplitude. Okay? So I ask you in one of the questions, how does A affect? So I'll take one of the. So this is how A affects. So if A is positive, definitely you have your normal. Is this what sign? Yes. So if A is positive, of course it begins from origin. A positive is the red one. Let's try to enlarge that. Okay. So this is sine. Okay. For the red one, that's the original stuff. We start from the origin. You can see that. But when A is negative, which is this black one, when A is negative, so rather than going up, the black one, there's a flip. And we have done that in function, so this is not new. When you have f of x, and when you have negative f of x, negative f of x gives you the reflection of f of x. We have done that in topic 2. So some of the properties that you have done in topic 2, especially the transformation of functions, applies to any function, and trig function is still any function. So it's not like, oh, there's a peculiarity, oh, there's a different thing that works for trig. No, this works for all functions. Algebraic function, trigonometric function, we have done logarithmic, you can see that. We use exponential function, we can see that also. Remember exponential function as well. So this works for all types of functions. So don't be surprised that when the function is negated, there's a flip. This is what we expect. And when you have the blue one here, when you have a number smaller, okay? Look at when the number is smaller. Where's the blue one? This one. Okay? So you can see that the amplitude reduced by half. So this determines the amplitude. Okay? That's why she made a comment there. If you look at that, I think I've scrolled that already. That determines the amplitude. But of course, the amplitude cannot be more than 1. Okay, regardless of, maybe not in this case. If you have this, I mean, the sign does not go beyond 1 and minus 1. That's what I mean. So if you have other number, then your amplitude might be seen. And as you can see that here, this is when you have 2. Okay. And if it is minus 2, it's going to be below at the reflection of that. Does that make sense? So we have to be very careful. So this determines the amplitude. Basically, this is what I will expect you to know. Basically, whatever number you have here tells you where the maximum of y is, basically. Because this can either be plus or minus 1 at the maximum. Okay, we'll see how this maximum can be used in word problem, hopefully for the end of today, because there's a lot of things I need to do. Now, also, I ask you to plot for these ones, and these are the curves. And the question that follow, I asked for period, and of course, we got 2 pi over b, which is very good. Now, what is that? So let's look at it one by one. How we got pi is equal to 2 pi over b as a period. Of course, the period is that interval of the repetition, right? Remember? What is the length of that interval where you have a complete circle before another one begins? If you look at the sine itself, it doesn't begin until, okay, maybe I go to decimals. Yeah, that is decimals. I gave you a different one because that's 4. I'll just get rid of this one. Make that. Okay. let's have sine. What are the other functions? Okay, sine x, 2x, half x. That is just a different number. Okay, this. So I'm looking at from 0 to 2 pi. Let's see. So, one circle hangs here for this one. Okay, 2 blue. All right. Okay, you can see now. Now, for the sine itself, when b is equal to 1, the I shouldn't go through all this if we have all done this. Thanks to my friends, we have to do that. Can you help please? When b is equal to 1, so in sine x, b value and period. Let's try to see the relationship. When you have sine x, of course b is 1. Sine 2x, your b is 2. Sine half x, your b is 1 over 2. Right? Now, let's look at the period in each case. So for the first one, can we see? Hopefully. For the first one, which is blue, the period is 2 pi, right? Isn't it? For the second one, 2x, the red one, the period is pi. And for the one with half x, this one, the period is 4 pi. So this is where the relationship comes. Okay? So basically, what is the connection between it? You can see clearly, oh, actually, you divide this by this. You divide b by 2 pi itself. So this is basically 2 pi divided by 1. This is 2 pi divided by 2. Because you remember this, there's a transformation from here to here. So this is like the base function, sort of. So the original 2 pi, okay, the initial, or should I say the index period, divided by these values of p, gives us the period of subsequent function. That's how that conclusion in one of the answers that I showed you was reached. And of course, we expect the same thing to happen to cosine, even though the investigation was not on cosine, we'll expect the same thing. So let's get rid of these guys. Cos 2x, cos, let's say 1 over 3x. Maybe we're just lucky the first time. Okay, they're in different color. Okay. So let's look at the first one. Cos x, cos 2x, cos 1/3 x. B here is 1, 2, and 1 over 3. The period for the first one, that is red. From 0 to, where is that? You see, the period, because the period is where you have everything repeat again, right? So if you start from here, you have to go back up. So that's where? What? Aha, here. So such that this is like a semicircle, right? So this is like one quadrant combined to be the semicircle also. Do you get what I mean? Because remember, everything looks like a circle being cut and spread around. So start from here. This is one complete 180. This is 90, 90, so you have your 360. So you have your 2 pi. Yeah? So for the 2x, which is the one in green, also start from here. Come here, come here, come here. Extend hands here. That's pi also. For the 1/3 one, so you start from here, goes down, comes up, and this is where it stops. Okay? So the period here is 2 pi. The period here is pi. The period there is 6 pi. What does that tell you? The base one is 2 pi. When divided by 2, you get this one. And when divided by 1/3, you get this one. So for sine and cosine function, the period is always 2 pi divided by b, where b is the coefficient of x. And that's how they got that from their investigation. Everybody, almost everybody that submitted this figured that out. Alright, so quickly, because of our time. So here is another part of the investigation. Okay, we figured this out already. So we noticed that when we had something in the bracket, it moves it. It's a translation, okay? This is the horizontal translation. So it's similar to what we know from functions also. If you have f of x as a function, right? Randy? If you have f of x as a function, f of x minus a translates the original function, a unit to the right. This minus is always default. So the sign of this number determines whether right or left. And if this a is positive, this minus, like I said, is there. But for the next thing that follows, determines whether left or right. And we have also learned that if you have maybe f of x plus b, then you're talking about the vertical translation. The same thing applies to this trig function. And that is why we have this comment in number 4, 3, and 4. Okay? And here, this is just for the general one. Sequence of transformation. Okay? So somebody wrote sine x is horizontally stretched. Scale factor 1 over b. So if you look at it, from the stuff that I showed you here, there's a stretch, isn't it? From the red one to the purple one. You can see, there's a stretch, right? And one thing about stretching, when we did transformation, vertical stretch is just multiply the exact number, right? Horizontal stretch happens to be the reverse. It's a division. Remember this? So the same happens here. So it doesn't, so when you have f of bx, the horizontal stretch is not b. Actually, f of bx simply means f of x divided by 1 over b. So the scale factor is 1 over b. Because your horizontal stretch, from what we have noticed in chapter 2, topic 2, is that while vertical stretch looks like the exact scale factor multiplies, in this case it is divided. The scale factor is divided by x internally, like a point. Does that make sense? So, and that is what that person, I think that's Clarissa, was trying to say. So, there's a horizontal stretch of 1 over b, because of course this is your x, right? Okay. And of course there is a translation. You can use vector directly. There's a translation by vector CD, positive C and positive D. Okay. In one of the questions that I typed out for you, the question asks for 5 transformations, but actually there are 4. The only difference, the only thing is this question is asking you to describe the vertical separately, horizontal separately. Yes, sorry. Won't be what?
The vertical translation blocks. So you can put it back.
Oh, that's why you have to separate
I don't
them.
think it would matter.
Yeah, me too. I don't think it should. Because if you have already f of maybe bx, okay? Are you sure?
As long as you translate horizontally first.
Yeah, because horizontal translation of vertical doesn't really affect whether you stretch or anything. So I don't think it matters. Yes, I agree with that. Okay, I don't think it matters. Okay, so in one of the questions, like I said, you might see the same question in other sources, asking for 5 transformation. So when the question is asking for 5 transformation, it means break it down, the vertical and horizontal translation. But the question is talking about just 4, like I did in one of the worksheets that I'm going to print, or maybe in this one that I printed, I specified just 4. So which means I expect a vector, because the vector has 2 different, 2 transformations combined. Is that understood? So that's that about that, and that should explain this. So this is obtained by, you see even here, okay? So you can keep this to last, because after you do all the stretching, compression and all that, then you can move it around vertically and horizontally. So this is advisable to even be the last, okay? So you can see this is obtained by this with vertical stretch, okay, of that, horizontal stretch of that, reflection, if A is less than 0, because if A is not less than 0, there's no reflection, right? And the translation through that. Okay, so we need to, and this happens to it. So if you want to copy this twice, fine. If you don't want to, just write at the beginning, sine and cosine, write the 2, this one followed by this exact one, then explain this once. And when you write this, or, okay, this one, or this one is obtained from this or cos, right? Then this is the same. Do you understand? Just to avoid too much writing. Understand what I just said? Do you, I don't want to have to read. Do you understand what I mean here? Okay, great. No time. So that's that about the first one, and I have this for you. I don't want everything done now, so I'm just going to picky. So in question 1, I want you to look at, now, I want you to do 1B, 1, 2. Please take notes. 1, 2, everybody please take notes. Number 2 in 1, number 4 in 1, number 5, and number 7. 1, 4, 5, 7. Then for number 2, I want you to do just the last 2, 2 and 4. 2 and 4 is on the next page. Okay. Then number 3, can you do 2 and 3? Number 3, 2 and 3. Number 4, maximum. Now, I need you to understand what maximum is all about. Sine is always between what and what, like I said earlier? 1 and negative 1. So, when you are asked to find maximum, you know that at maximum, this, from this word S to this point is 1 for maximum. Not everything is 1. It is only the sine function that doesn't go beyond 1. And so that is the purpose of this, to extend it beyond that maximum point. That's the purpose of this amplitude. Okay? Anyway, what I'm trying to say is, so when you're finding your maximum, this will be 1. Then you just substitute 1 for this sine part only. And for minimum, you just substitute minus 1 for this part. And whatever you get is your maximum value and minimum of that stuff. Does that make sense? Okay. So the maximum, minimum, just do question 3. That's number 4, question 3. Let's see which one. So you can try question 5 on your own. Number 6. You can ignore 5, but you can do 5 later. So in question 6, I've tried to put a sketch of sine and cosine, and I need you to now draw those functions that I've indicated. I did the same thing for topic 2, if you remember. I give you a function, I ask you to draw the other one without using calculator, without checking online. Just try to sketch based on this transformation stuff. So I'll say just do a few ones. So that's that and that. Then at the back, there are finding the value of something. So I want you to maybe practice 11a. Okay. 11a, for example. That's on page 4. Okay. Then go to page 7. Please check 13a. So if you have the curve, how do you find the value, the equation? Okay. So I think others are just applications. Go to 15. Maybe the last question in 15. That's 15D. So if you can do that, I'm going to circle this. These are from exam question. When I step to this, I give to you also. This is just to discuss among yourself. Of course, when you get home, you take your time to do the rest. Okay. So try as fast as possible to discuss. This is for the calculation. I assume you will see her again. Right? Yes, sir.
For the first question, it means y equals sine x or cos x, right?
I thought I said number 2. And then that's for 1, but if you do 1,
Isn't that 1, 4, 5, 7?
okay, that's fine. But I thought I mentioned 2, not 1. But it's okay. Translation by vector 0 minus 1, that's correct. But don't just write translation by vector 0 minus 1. Okay? What does the statement say? State the transformation that maps this to this. Okay? So you can say y equals sine x was translated by vector. Which one was translated to give which one? So you have to be able to explain. That's why I gave you 2 lines. Okay? Y equals sine x was translated by vector minus 1, 0 minus 1 like you wrote. Let's know which one was translated to give which one. You should start this now instead of writing it and copy this later. If you need a picture of that, I send to you. But I'm sure you have your textbook at home, right? You just indicate the page number. It's 455. Then you can write as much as you want to write. What's the problem? Yeah, what happened? You don't know what to do. It's just to state what transformation. What happened to this one? Oh, because I put cos. Sorry guys, I think I meant to use the first one as just sine. Then I decided to add cosine function. So it should have been, the original question should have been that maps y is equal to sine x or cos x. So can you add that? Question 1 of the first activity. So change it to sine x or cos x. I think when I was compiling the question, I started with sine. Then I decided rather than create another question for transformation, I just combined both and I forgot to change the heading. Thank you. Again, confirm. The second worksheet that I've just passed out, I took questions from exam style papers. Okay? So, after you learn these basic applications of transformation, okay, or this transformation in sine and cosine, how do you apply it in the exam style question? So that's where I got the one in 4 pages, 7 questions only. We don't have to do any of them in class, but please do it at home. Because the next class, which is about 11, I'll be doing something else. Then you have your own months to do whatever you want to revise on your own. My goal is to finish everything in the first week of school, because now we can't finish it during the holiday. so that vectors can be completed latest by end of September, and we can have calculus for 3 months, or even third week in September. September, October, November, actually September to October, October to November, November to December. So 3 months of calculus. And statistics, January, oh my God, it's Chinese New Year, none of this one. Well, we're going to have to include some weekends, but we're getting there. The most voluminous part is what we're about to do, that's calculus. Practice with someone, discuss, if you have to, it's allowed. Where's the other one? When you're trying to find your, what is it called now, period, you just pick B. Because remember we said period is 2 pi over B. Just pick the value of B and write period is equal to 2 pi over that value of B. That's it. Okay? And if you're trying to find the value of B, you have an equation now. We're going to be using that equation a lot. Period is 2 pi over B. So always refer to this, which means B itself is 2 pi over period, right? So you just say from period is equal to 2 pi over B. And you can use that. I'm referring to question 3. Okay. But question 2 is easy, right? Just write period is equal to, I think both of them, 2 and 3, you should write period is equal to 2 pi over B. But 2 and 3. Everything all right? So for question 2, you should state this first. Okay? Period is 2 pi over B, which is equal to blah, blah, blah. For question 2. Therefore, question 3, I expect you to say from period equals 2 pi over B. Then you put your period. This is known. And this is not known. Then you can cross multiply and solve for B. So you need to justify what you're doing. So the one that has to do with number, so when you divide definitely, you get decimal. Okay? Or just something over pi. Of course, pi and pi will cancel, you can't leave that. In this case, yeah.